Welcome back to another episode of Algebra 1. We are today working on section 3.4, and our objective today is going to be graphing linear equations from standard form using x and y intercepts. Graphing linear equations in standard form using x and y intercepts. It's important, x and y intercepts. All right, if you would turn with me to page 75, we're going to check out what is the standard form. So here on page 75 we have a problem. You sold a total of $48 worth of cheese. You forgot how many pounds of each type of cheese you sold. Swiss cheese costs $8 per pound, and cheddar cheese costs $6 per pound. So, let's check this out. Let x represent the number of pounds of Swiss cheese. So Swiss cheese is x. Let y represent the number of pounds of cheddar cheese. So here's cheddar cheese, which is going to be y. Use the verbal model to write an equation that relates x and y. So up here we know we have a total of $48, and Swiss was $8 a pound, and the cheddar was $6 a pound. So there is your equation. 8x plus 6y equals 48. Okay, so that's your equation, and that is written in standard form. This is standard form. If you want, we can go to the Desmos calculator, and we can see what this looks like. 8x plus 6y equals 48. So there's our graph right there. There's our linear equation written in standard form. That is our line. So let's carry on. Solve the equation for y, and then using a graphing calculator, graph the equation. Okay? So solve the equation for y. 8x plus 6y equals 48 minus 8x minus 8x. We then have 6y equals negative 8x plus 48, and then we divide by the 6 all the way across. So we have y equals negative 8, 6 x plus 8. Negative 8, 6 x plus 8. All right. So there we just solved for y. We could simplify this. This can be divided by 2 over 2. We get negative 4 thirds x plus 8. So there we go. We just solved for y. Now, what if the x-intercept is the x-coordinate of a point where the graph crosses the x-axis? We're going to talk about that quite a bit today. The x-intercept is where a line crosses the x-axis, and the y-intercept is the point where it crosses the y-axis. So if I have a line, and it goes like this, that point, I should always write my x and my y on my graph. That point is the y-intercept, and that point is the x-intercept. It's where the line crosses over the x-axis, and the y-intercept is where the line crosses over the y-axis. All right, so use the graph to determine the x and y intercepts. So if I go back, so we graphed it out on the Desmos calculator. Here is my y-intercept. So y-intercept is 0, 8. My y-intercept is 8, so my x value has to be 0. So there's my y-intercept at 0, 8. It says right there. And then I go down here and I find out where it crosses the x-axis. And it crosses the x-axis at 6, 0. So I wrote those down. The y-intercept crosses at 0, 8. My x-intercept crosses at 6, 0. And I saw that on the Desmos calculator. How could you use the equation to find, how can you use the equation to determine the x and y intercepts? Well, we could use them by turning x to 0 or y to 0 to find the intercepts. Example of that, let me just show you what I mean. If we have this equation, which is our original equation, and if I make a table, if I turn my y-intercept to 0, I will find my x-intercept. So, turn my y-intercept to 0. 6 times 0 is 0, so I have 8x equals 48. Divide by 8, divide by 8, I have x equals 6. Yep, sure enough, there's my x-intercept. Likewise, if I turn my x value into 0, I have 8 times 0 plus 6y equals 48. So that's 0. So I have 6y equals 48. So I have y equals 8. Hey, look, 0, 8, 0, 8. That's my x-intercept. So if you want to just find your x and y intercepts, excuse me, without using the Desmos calculator, there it is right there. You just plug in 0 for y. That'll give you your x-intercept. Plug 0 in for x, and that'll give you your y-intercept. Okay, if you'll move with me to page 76, we're going to do a few definitions. So, standard form. Standard form is a linear equation written in the form of a times x plus b times y equals c. That's standard form. An example of standard form, sorry about that, an example of standard form might be 2x plus 3y equals c. There's an example of standard form. Alright, x-intercept. What is the x-intercept? Well, that's where a line, it's the point where a line crosses the x-axis. So, if I were to have this graph, and I have a line that goes through these 2 points, get a nice little ruler so it looks good. I have a line going through these 2 points. My x-intercept is where it crosses the x-axis. So my x-intercept is 3, 0. Now, this is the point. The y-intercept is the point where a line crosses the y-axis. Point where the line crosses the y-axis. So here, it crosses at 1, 2, 3, 4, 5. So it crosses at 0, 5. There's my y-axis. Or my y-intercept, excuse me. My y-intercept. I have got to get in the habit of labeling these. Okay. Now, take note of this, please. This is an important piece that students wrestle with every single year. Horizontal and vertical lines. If I have y equals a number, I'm going to have a horizontal line. If I have x equals a number, I'm going to have a vertical line. Let me show you what I mean. If I have y equals negative 2. That's a linear equation. And if I write out a table for this, xy, well, what's my y value going to be for every single number here? What's my y value going to be? Well, it's going to be negative 2 because y equals negative 2. My y value is going to be negative 2 there, it's going to be negative 2 there, it's going to be negative 2 there, it's going to be negative 2. It does not matter what number I pick, my y value is going to be negative 2. I could pick 0, I could pick negative 2, I could pick 4, I could pick 1 million, and my y value is 2. So how does that look when it's graphed? Well, if I have my y and my x-axis, y equals negative 2, so 0, negative 2, negative 2, negative 2, 4, negative 2, 1 million, negative 2, everywhere it's negative 2. I have a horizontal line. When y equals negative 2, I have this horizontal line. It never leaves negative 2. It is always negative 2. So if you have trouble with that, just look, y equals negative 2. Just put a bunch of negative 2's in for the y value and then graph it. Now, on the same note, if I have x equals 5, well, let's do a table for this one. X equals 5. Well, what does x equal for this number? Oh, 5. This one? Oh, 5 again. Oh, 5. What about this? How about put every single y value, x equals 5? Because that's what it says. That's our linear equation, x equals 5. So this could be negative 10, this could be 2, this could be 5, this could be negative 3, this could be negative 100 million. You get the point. No matter what my y value is, my x is going to be 5 because my linear equation is x equals 5. And what does that look like when I draw that out? Well, my y-axis, my x-axis. Well, x equals 5. What about for 2? 5, 2, 5, 2, 5, 5, 5, negative 3, 5, negative 100 million. There it is. That's my line. No matter what, my x value, no matter what, my x value is 5. So it's a vertical line. So these cause people a lot of trouble, these horizontal and vertical lines. So whatever it takes to remember that, remember that. All right, moving on to page 77, extra practice. All right, y equals negative 3. So let's make our table. X, y. Y equals negative 3. Negative 3, negative 3, negative 3. Y always equals negative 3. It looks like they started us off with these horizontal and vertical lines. So what's my x value? It doesn't matter. Negative 2, 0, 2, 1, 10, 1,000, 5. So I have negative 2, negative 3, negative 2, negative 3. I have 0, negative 3, 2, negative 3. Oops. 0, negative 3, 2, negative 3. Every single y value is negative 3. So there it is, negative 3. All right, here we have x equals 2. So let's do the same thing. Let's do an x, y, x, y. My x value is 2, right? X value is 2. My x value is 2. So for these horizontal and vertical ones, they're actually easier because I can just make up whatever numbers I want for here. I really like 100 million. I can make up whatever numbers here. All I know is that my x has to equal 2 no matter what I have. So I have 2, negative 1, 1, 2, negative 1, 2, 0, 1, 2, 0, 2, 10, 210 would be up here. So there we go. I've got this vertical line. There it is. X equals 2 is a vertical line, just like that. All right. Let me go ahead and do the odd ones for you, and then you'll be able to do the rest. Find the x and y intercepts of the graph of the linear equation. So how do I find these? Most of the time I want to just do a table. And so for finding my x, I need to turn my y into 0. For finding my y, I need to turn my x into 0. So what if I plug in 0 for y? Well, I get 3x plus 4 times 0 equals 12. 3x plus 0 equals 12. Divide by 3, and I have x equals 4. So there we go. I got my x-intercept is 4, 0. That's my x-intercept. How about my y-intercept? Oh, I don't have quite enough room here, so let's grab a piece of paper. Three x plus 4y equals 12. And now I have to put in a 0 for my x value. So 3 times 0 plus 4y equals 12. That's 0, so I have 4y equals 12. So I have y equals 3. So there are my x and y intercepts. And that's all I have to do is find the x and y intercepts, so I don't even have to graph it. Although if I wanted to graph it, let's look at this one. Let's look at this one on a Desmos calculator. If we had, the equation was 3x plus 4y equals 12. And what we should get is our x-intercept is 4 and our y-intercept is 3. What would you look at that? Right there. Y-intercept is 0, 3, and our x-intercept is 4, 0. Perfect. We did it right. All right, number 5. 5x minus 2, y equals negative 30. So we're going to do a table again. We're going to do our xy table. To find our x-intercept, we need to turn our y into 0. To find our y-intercept, we need to turn our x into 0. So let's go for the x-intercept first. So we'll turn y into 0. So 5x equals negative 30. Divide by 5, divide by 5. And we get x equals negative 6. Now we have to find our y value, our y-intercept. So we turn our x into 0. So we have 5x minus 2y equals negative 30. That's our equation, right? Now I have to plug in 0 for x. So plug in 0 for x. 5 times 0 minus 2y equals negative 30. So 0, so I have negative 2y equals negative 30. Divide by negative 2, get y equals 15. So, what I should have is an x-intercept of negative 6, 0, and a y-intercept of 0, 15. Those should be my intercepts right there. So let's go check it. If I have 5x minus 2y negative 30. Alright, here we go, negative 6, 0. That's what I got, negative 6, 0. And then we have 0, 15. Oh, let's check. Oh, look at that, 14, 15, 16. 0, 15. Perfect. Alright, we're crushing it. Okay, let's look at the next. Let's go ahead and do number 6. Use intercepts to graph the linear equation. Label points of corresponding intercepts. Negative 8x plus 12y equals 24. So I need to find my x and y intercepts. So I need to plug in my zeros. Negative 8x plus 12 times 0 equals 24. So negative 8x equals 24. The only reason I cross that out is 12 times 0 is 0. So I don't need that. Divide by negative 8, x equals negative 3. So I have negative 3. And then let's do the same for my y value. So I have negative 8x plus 12y equals 24. So I'm going to plug in 0 for my x value. Negative 8 times 0 plus 12y equals 24. 12y equals 24. Divided by 12. Y equals 2. So what does that tell me? That tells me that my x-intercept is negative 3, 0, and my y-intercept is 0, 2. So let's plot those. So negative 3, 0, I have 1, 2, 3, negative 3, 0, and then 0, 0, 2, 0, 1, 2. So there is my line. That's my line. All right, go ahead and do number 7. And yeah, see how you do. If you have questions, let me know. Number 8, big word problem. I'm going to get you started on number 8. Then you can finish it. The school band is selling sweatshirts and baseball caps to raise $9,000 to attend a band competition. Sweatshirts cost $25 each and baseball caps cost $10 each. The equation 25x plus 10y equals 9,000 models this situation where x is the number of sweatshirts sold and y is the number of baseball caps. Alright, find and interpret the intercepts. So if we have 25x plus 10y equals 9,000, how are we going to find the x and y intercepts? Well, how do we find the x and y intercepts every other time? We plugged in 0 for y for the first time, did it again, we plugged in 0 for x. That gave us our x and y intercepts. If 258 sweatshirts are sold, how many baseball caps are sold? How would I do that? Well, sweatshirts is x, so I would plug that in from x value and solve my problem. Graph the equation, find 2 more possible solutions in the context of the problem. So find 2 other places where you get a certain x value and a certain y value, and you come up with 9,000. Alright, do your best on that assignment, enjoy it, and please call or ask if you have any questions. Thank you so much.